Okay, so today we are doing the fundamental counting principle. How exciting for you. It's really easy. Basically, because we're going to be starting on probability, we have to know like number of possible outcomes, because with basic probability, it's a favorable event over the total number of possible outcomes. So the fundamental counting principle is basically where you multiply, what was I calling it? You multiply all the possibilities, or I should say the number of all possibilities. Anyway, so for example, if you are rolling a die, there are 6 sides on a die. And if you are tossing a coin, there are 2 sides on a coin. So all the different possible combinations will add up to be 12 different things. Pretty simple. Basically, the way you got to think of it is anytime you do something, so like you're rolling a die or you're tossing a coin, you just have to multiply a number by however many outcomes there are. This, I forget, I put this in last year and I don't remember why, so I'm just going to skip it. But anyway, so this would be an example of like a type of word problem you might see that has to do with the fundamental counting principle. And basically, anytime you're making a choice for your sandwich, you just multiply how many options you have. So 6 times 4 times 5 times 5, which would be 25 times 4, which is 400. Yes. 600. Ooh, that was ugly. 600. Much better. Ta-da. Anyway, okay. For example, Kentucky license plates. Now, once upon a time, they always put numbers on this side and letters on this side. I don't know if you guys have noticed, but they recently flipped it. I don't know if they like ran out or they're just, I don't know why, but now it's like the letters over here and the numbers over here. But it's still the same concept. So with numbers, there are 10 different choices because you got to include 0. So it would be 10 times 10 times 10. And then for letters, technically, it would be 27, except I happen to know that with license plates, they don't use the letter O because it looks exactly like 0, which is just a fun fact for you. But anyway, so basically 26 times 26 times 26, which I don't know what that is. It's 1,000 times something. 1,000 times 26 times 26. 17,576,000. Well, is there 26?
Yeah. I think it's 26.
Oh my gosh, I've been doing this wrong all day. So it should be, well, let's just pretend like they use O. I thought there was 27. Oh gosh. The other day I couldn't even think of what 12 squared was. I was like, my brain has turned to mush. Anyway, so if they used O, there would be 17,576,000 different possible combinations for Kentucky license plates, which now they also changed it so that like they're together, which is weird. I don't know. Kentucky never makes very nice license plates. Do y'all remember when no, you all probably not even born. When I was in high school, they had this like sunset with like a little sun in the middle with a smiley face or something. It's like the ugliest license plate. Were you all born? People used to buy like stickers to put over the sun because it was so stupid looking. Anyway, okay. So this one is a little bit different. Well, I mean, it's the same thing, but a little different because it's kind of just, well, you'll see. Okay, so there's 8 spaces. 4, 5, 6, 7, 8. 8 spaces on a wall. And you're hanging eight paintings. So for the first spot, you have 8 choices, right? Like 8 paintings to choose from. But then you're going to hang one up, and then you just have 7 left to choose from. So we'll kind of talk more about this tomorrow, but basically, as you go down each time, you hang up a painting, so you have one less option for your next spot. So you would then, so if you're looking for all the different combinations of ways that you can hang up all these paintings, you would end up with 8 times 7 times 6 all the way down. And that, my friends, is a factorial. So if you ever see a number with an exclamation point at it, it's not just a really excited 8. It is telling you that you start at 8 and multiply by 1 less all the way down till you get to 1. So like, and it works if you had like 5 factorial, it would be 5 times 4 times 1. So that's just what that means. Okay. The nice thing about factorial, they're kind of like this strange random thing in math. But GeoGebra and Desmos does do them, so you don't have to, like if you had like 27 factorial, you wouldn't have to write out all of them, so that's exciting. But anyway, if you were trying to simplify factorials, the best way to do that, so I have 10 factorial, which I'm going to start going down times 9 times 8. And then when I get to 7, I'm just going to stop, because then these two can just cancel out. Like they'll just go away. And then, with the next one, I would always cancel out with the bigger one. So 15 times 14 times 13. And then, but like if it cancels out here, you can't then make it go smaller and cancel out the 3 and stuff. Oh, I forgot to actually say that that'll be 720. But this one is 15 times 14 times 13, 3 times 2 times 1. So, just for fun, if you ever did want to like do some more mental stuff, like because there's a 3 inside 15, you could cross that out and make it a 5, and that 3 would go away, and the 2 inside the 14 could go away. So you just end up with 35 times 13, which I don't know how that is. 455. Did I do that right? Yeah, that's what I got earlier. Okay. Cool. So anyway. Yay. Fundamental counting principle and factorials. How exciting.